Hello everyone. This is the next class of petroleum geology. As we know, we have studied till now we have studied what is petroleum and what are the occurrence of petroleum, what is the mode of origin of petroleum, how they occur, and what are the ingredient which is responsible for the generation of hydrocarbon. Apart from that, what are the physiochemical condition which are responsible for the generation of hydrocarbon. In the last class we also studied what are the key element which need to be discussed to know the entire petroleum geology. Out of them, the first one was source rock, which we studied in great detail. What are the source rock, what are the type of source rock, how they transform, how a source rock is getting transformed into petroleum, and then how do we do rock evol analysis, S1, S2, S3 peak. Then after we discussed about the reservoir. For reservoir, as we know, it should have porosity and permeability, and we had discussed about porosity and permeability. Now we will discuss the next key element of petroleum geology, that is the seal. So as we know that for accumulation of any petroleum, what do we need? We need a source rock where the petroleum is getting generated, and a trap where the petroleum is getting accumulated. In between we have the reservoirs, but for reservoirs to trap the hydrocarbon we need a impermeable layer, and that impermeable layer is known as seal. Okay, so reservoirs, what is the reservoir seal? Reservoir seal is an impermeable rock which retard the migration of further upward migration of hydrocarbon. And usually in all over the world, the most common reservoir seal rocks are evaporite, shale, and carbonate. Okay, so the best seal is evaporite, which is imporous, impermeable, and the second is shale, and third is carbonate. Okay, but as for the abundance, if we talk about abundance, the most of the seal, like 65% of the seal are made up of shale, whereas 33% are evaporite, and carbonates are very less as compared to shale. Okay, so if there can be two kind of question, which one is the best seal? So which one is the best seal? The evaporite is the best seal, whereas which one is the most abundant seal? Most abundant seal is the shale. Though shale is slightly shale has porosity and porous but impermeable, so shale can act as a good seal. Okay, so if, here in this pictorial representation we can see how the accumulation of hydrocarbon takes place, and we can see this is an anticlinal structure. Over this is shale, as we can see this one is shale, which is acting as seal, shale. This is shale which act as seal, and this one is our reservoir. Okay, this one is our reservoir, and the hydrocarbon is being migrated somewhere either from lateral side or from downward side and getting accumulated on the crustal part. It's got accumulated on the crustal part, and if we see, the density of gas is lower than the water and oil, and further density of water is further lower. That's why they are getting segregated as per their density. What is the density of gas? Anybody? Usually, yes, some of you may be knowing. Usually the density of gas we take around 0.3 gram per cc, and for oil the density is in general 0.7, but it varies with the specific gravity of oil or API gravity of oil, which we have already discussed in the first class of petroleum geology. But usually in general 0.7, whereas for water is you must have studied in your schooling also, the water has usually we take it as 1, but in general it is 0.9 for 0.93 for fresh water, and for marine water it is more than 1.07 or something. Okay, so this is how the oil the hydrocarbon gets accumulated. At the top we have the gas. Why the gas occupies the top position? Because of its lighter weight. Okay, and followed by oil, followed by water. Okay, the for any structure there is a term called spill point. Okay, so what is a spill point? A spill point is a point below which we cannot get any structural closure. Okay, and this is the maximum limit up to which we can get an accumulation of hydrocarbon in any structure, and that is known as a spill point. Okay, and the contact of this portion we call it as gas cap, this portion we call it as oil zone, and this portion we call it as water zone. This structure we have already studied in the first class, where we were discussing about undersaturated, oversaturated and saturated reservoirs. You must be remembering that. So which kind of reservoir it is? It is kind of saturated reservoir, where to explore this kind of structure, what do we need? We have to drill wells on the flank so that we can get the water drive from the bottom and gas drive from the top, and we can have the maximum production. Okay. Over here in general usually we have two type of water drives. One we call it as edge drive and another we call it as bottom water drive, and after spill point usually we have the edge drive. From the edge the water pushes the hydrocarbon towards the drilled well, whereas from the bottom side we have above the spill point we have the bottom water drive. Okay, and this as we have already discussed, the whole structure from the top crustal part of the structure to the spill point we call it as structural closure. Okay, related to this we have a principle which we call it as Gusa Principal, and what is this Gusa Principal? This Gusa Principal says that if we have any anticlinal structure like anticlinorium type of structure, something like this, we have successive folds which are moving upward, and hydrocarbon is getting accumulated in this. So what will happen? Suppose while migration is taking place, oil, water and oil, water, gas, oil and water, each of them are getting migrated from this place, then what will happen? How they will migrate? So what you expect? What we will get over here, oil or gas? Most of you will say because gas is lighter we will get gas over here, but that is not correct. What is the reason? Because the instant when migration takes place, initially the first structure which is getting filled is this. Okay, this structure will getting filled, so initially the gas will accumulate over here. Okay, because the first escape out of them, the first escape will be for the gas because of its lighter nature and incompressible in nature, so it expands very fast. So the first structure will be filled by gas. Later on over here we will get gas and oil. After spill point over here we will get oil and water, and at the last we will get water with some amount of oil. Okay, this is how the distribution of oil and gas will takes place in a series of anticline moving upward direction. So this is known as Gusa Principal. Okay, so this is additional information which you need to know. Now this is additional information which you need to know. Now we will move on our next topic. This is about the seal, and next come trap. The fourth component of petroleum, the fourth key component of petroleum is trap. What are the trap? Traps are some structure or geological construction, geological configuration which are responsible for the accumulation of hydrocarbon, and it restrict the further movement of hydrocarbon. Okay, so now you can question, then what is the difference between trap and seal? Seal is just a covering above the reservoir. Okay, and trap is a combination of reservoir along with cap rock. Okay, so that is known as trap. So what is trap? As the definition says, this definition has been taken from Leverson book. You must be knowing Leverson is a book of petroleum geology, writer of a book of petroleum geology. So from that book this definition has been taken. What does this definition says? It says place where oil and gas are bad for further movement. Okay, so that means after this oil and gas cannot move, or hydrocarbon or petroleum cannot move, and that point is known as trap. Okay, so as for the literature is concerned, we are having three type of traps: structural trap, stratigraphic trap, and combination of the trap. And when we were discussing about the occurrences of hydrocarbon, over there we discussed how much abundance of hydrocarbon will occur in structural trap, how much in stratigraphic trap, and how much in combination trap. We have very little, less than 1% accumulation in combination trap or combined trap, whereas maximum accumulation around 75% accumulation we usually get in structural trap. So what are these structural traps? Structural traps, these are some jargon in general. So what is structural trap? Structural trap means where any structure is responsible or any structure is involved for the generation of those traps. And you must have studied in structural geology what are the basic structures. In general, the main structures are fold and fault. So usually the structure traps are associated with folding and faulting or combination of these two. Okay, they are mainly considered as structural traps. And how they form? They are formed by low deformations, that can be local deformation or that can be regional deformations. Okay, when there is local deformation, then that kind of structural trap is known as pool. When there is regional deformation, then that kind of structures are known as province. Okay, or field. So next question come, how do we determine what is the extent of our structure which we are dealing with? Because to demarcate the structural trap, to identify the structural trap, what do we need? We have to map that. Being a geologist, what should we do? We have to map that structure. So to map that structure, what are the data required? Being a geoscientist, from BSc classes we used to go in the field and we map these structures. All of you must have done the same thing. So that comes under structural mapping or structural mapping. What do? We go along the roadside and measure the dip along the roads and plot that using the like as we do in the structural geology classes. and subsurface, core drill and geophysical. These are some mapping, some methods which are used for structural mapping. I will not go in much detail, but how do we do these mappings, that I will discuss a little. So like first is surface mapping. You must be knowing better than me, even I will say. In structural mapping, what do we do? Suppose there is a road cut. Along the road cut, what do we do? There will be inclined strata which is going on. So we measure the dip and strike of each of these strata along the road sections, and suppose they are dipping in opposite direction. This is how we measure. This is the representation of dip and strike, you must be knowing. So what do? We usually join strike along with the strike to determine the beddings. This is how the bedding are dipping, and we can infer. This is the map. This will be a map. Okay. This was the bed boundary. Along the bed boundary, what did we do? Along the bed boundary, we measured the dip and strike, and based on the dip and strike, we tried to interpolate in between, and we created a map. And based on this map, we can determine whether we are dealing with the anticline or syncline. So what is what do we require for hydrocarbon entrapment? Usually, most of the hydrocarbon are entrapped in anticline, though with some exception we can also get accumulation in syncline, provided there is phase variation or there is hydrodynamic prevailing hydrodynamic conditions that we will discuss later on in the combined trap. And in subsurface, what do we do? And core drill, like suppose we are drilling. These are actually interrelated: subsurface, core drilling and geophysical. Usually geophysical methods you will study in geophysics classes, but over here what do we do? Broadly in geophysics, what do we do? In geophysical method, there is seismic exploration. There is a chapter called Seismic Exploration. In this seismic exploration, we do seismic reflectivity survey and seismic refractivity survey. It is a separate subject. I am not going on that. But over here, what do we need to discuss? That based on that reflection, suppose this is the source and there is one receiver. From the source, we get reflection on the receiver, and we map the layers. From each layer we get reflection. Wherever lithological boundary are there, we get reflection, and when we have mapped the lithological boundary, then automatically we can map the subsurface structure. What is the architecture of that particular area or that particular locality, how it has occurred. Okay. And in core drill, what do we do? The core drill method we use is this surface exploration method, surface mapping method we used in initial phase of hydrocarbon exploration when we don't have any information about the area. Okay. Then we go for the geophysical method. By geophysical method we go for subsurface mapping. In geophysical method is the next step of mapping of an area, and the core drill is the last step of mapping of that particular area. What do we do in core drill? Usually suppose there is a structure and we have drilled several wells. We have drilled several wells, that this initial structure is being delineated by seismic method. Okay, this initial method has been delineated by seismic method. Then we have drilled the well. Okay, and in each of the well we have encountered a pay sand which is located at particular locality. Okay, suppose this is how this is GR log in general. So and this curvature represent your sand. Okay, so if we match the top of this sand, we can delineate how the structure is varying. Okay, this is used in development phase. Okay, so this is initial reconnaissance phase, this is exploration phase, and the core drill, based on drilling, how do we demarcate the structure, that is being used in advanced stage or development stage. Okay, this is how we used to deal with the, this is how we usually deal with the structural traps. Then what are different kind of structural trap? As we discussed, these structural traps are generated by the deformation, that can be local or regional deformation in the subsurface because of compressive or tensile forces which is operating within the earth. Okay, so these structural traps has been classified into two main category, folds and faults. Okay, so and we can say, if we see this map here, this is the map view and this one is your cross sectional view, and you all are good structural geologists, so you can easily depict any of these structures. This is a normal fold, okay, and this is overturned fold, this is overturned fold, and this is slightly tight fold. Okay, so in structural geology classification you will see normal fold, open fold, tight fold, how the classification varies. Over here we just need to know what are the structural configuration, how the hydrocarbon gets accumulated. This is open fold where we have accumulation on the top, and this one is slightly tight fold where we have accumulation again, and this is overturned fold. So starting from open fold to symmetrical fold, asymmetrical fold, or overturned fold, there is several classification, we need not to go into detail, but over here we can infer that the folds are a curvature which is responsible for entrapment of the hydrocarbon. Okay, so next comes about the fault. In fault, like intersection and combination of two fault can act for the accumulation of hydrocarbon. This is very clear, you can understand very easily. Like if we have any kind of like upward any upcurved structure and the hydrocarbon is getting accumulated in this upcurved structure, okay, upward curved structure. And in fault, how the accumulation takes place, it's really complex. Like somebody can say fault mein to kaise hoga, but over here what we can see, suppose this is a fault, this is a normal fault, and we have a porous layer, porous and layers. Suppose this is sandstone, and this is shale. Over here again, if this is normal fault, this block will go down, so which we call it as gravity fault also. So what will happen, this sand will come over here and shale will come over here, and suppose if the migration is taking place from this direction, then what will happen, the accumulation will take place over here. Why accumulation will take place over here? Because this is shale, and as we have already discussed in the cap, shale act as a source as well as cap. Okay, so this will act as cap for further migration of hydrocarbon. So the accumulation of hydrocarbon will take place over this place. Okay, this we call it as single curved fault or single fault. When the entrapment is associated with a single fault. Okay, then next come entrapment which is associated with combination of two fault, intersection or combination. In that case also, over here you can see this is one fault and this is one fault, this is up thrown side, this is down thrown side. Okay, similar way which we have discussed, this we have already discussed, and over here I think it is visible to all of you. So if we see, this is these are two fault, this is the plan view of the same, and we can see this is going down, this is going down, and accumulation the migration has taken place from this and accumulated over here, because after this in this side we have the shale which is acting as caprock or shield. Okay. And similarly in the combination of two fault in the similar way, and then there can be normal fault with low amplitude and high amplitude faults. Sometimes these structures are very common, or usually they are very common. In general we don't get, or we rarely get this kind of like open fold or tight fold. Usually we get folds in India. Usually we get faults associated with fault, and that fault can, that fold can be either low amplitude or high amplitude. So that this part is getting is usually studied under fault bend fold and fault propagation fold of your structural geology. Over here I will just briefly discuss. Suppose this is a fault, and usually the extensions and compressions are associated with also associated with little compression and vice versa. Okay. So if this is how structure is there and accumulation takes place over here, then we call it as normal fault with low amplitude fold. This is low amplitude fold. Okay. And if the compression is extremely relatively higher, then what will happen? Then we get this kind of structure, a tight fold associated with a fault, and we call it as normal fault with high amplitude fold. Okay. And that is the best explained by Digboy oil field of Oil India Limited, where we have this kind of structure where we are producing hydrocarbon in India. Where is Digboy? Digboy is in Assam. Okay, one of the main field of Oil India. Next comes stratigraphic trap. What are stratigraphic trap? As the name indicates, structure and stratigraphy. In structure, what are the processes for generation of structure? Compression and tensile forces. Okay, they are the main responsible, or they are the main cause for the generation of structural trap, whereas stratigraphic trap are usually associated with the either by the lithological variation which leads to the break in the migration of hydrocarbon. Okay. So as the definition says, these traps are result of lateral variation in the lithology that leads to the break in the continuity. What kind of continuity? That means the migration continuity. After that the migration will not take place. Okay. So this kind of traps, stratigraphic traps, are usually caused by change in the permeable to impermeable layer, or associated with the unconformity, or by overlapping of the sediments, or change along the bedding plane. Okay. These are the four causes which are responsible for the cause of change of lateral variation in the lateral variation in the facies. Okay. And when there is lateral variation in the facies, that will lead to entrapment of hydrocarbon. How? We will see in the next slide. Okay. Before that what we need to discuss, we can divide these stratigraphic traps into two categories, primary and secondary. Primary stratigraphic traps are syndepositional in nature. That means the lithological variation or lithological contrast or permeability porosity contrast that is being caused during deposition. How during deposition? Suppose you have a basin, a slope contains a slope, self slope rise, as you all know. So sediment is coming from this side. On the shallower side you will get coarser sediment, on the deeper side you will get finer sediment. Coarser sediment, usually what we take? we take as sandstone, and finer mein in general we take shale. So this is how lateral variation is getting created in a sedimentary basin. If such type of syn depositional lateral variation is there, we call it as primary porosity and primary stratigraphic trap, okay, and secondary stratigraphic traps are those traps which are formed, they are stratigraphic in nature, but they are formed by the breaking in deposition, like which are associated with the unconformity. They are usually associated with the unconformity, okay. And I would like to mention over here that the delineation of stratigraphic trap is really tough, because in general using the seismic data also you cannot easily demarcate where we are getting change in the lithology, though geoscientists used to try and infer the things, but it's really tough. That's why we need more number of drill well to delineate and test such kind of pools, okay, as compared to structural trap, because structural traps is easy to demarcate on the seismic reflectors. This is how this like suppose seismic reflector is moving like this, we can easily puncture this structure and we can get hydrocarbon. But if there is variation something like this, sand to shale, and boundaries are these, so it's really tough to demarcate up to what extent we are getting sand, up to what extent we are getting shale within a single layer, within a single formation, or within a single unit, within a single bed. So it's really tough to delineate them. So we require more number of drill well to delineate and test this structure as compared to stratigraphy, as compared to structural trap, okay. And next is this is one stratigraphic trap. And can you tell what kind of stratigraphic trap it is, whether it is primary or secondary? Very good. As you see here we have unconformity. Some of you are really good and you can demarcate very easily. Over here we have an unconformity, okay, and deposition of this phase is separate and deposition of this phase is separate. When we have two different depositional setting and they are coming together for the formation of stratigraphic trap, then we categorize them into secondary stratigraphic trap. So this is a kind of secondary stratigraphic trap. This is a kind of secondary stratigraphic trap where this is sand and this is shale, this is limestone, and the accumulation is taking place in the sand wherever we have sand, because the second lithology after the unconformity, the second lithology which is getting deposited after the unconformity is shale, and this shale is acting as cap rock and restricting the movement of hydrocarbon. So we are getting accumulation of hydrocarbon, and unconformity trap is quite easy to identify as compared to lithological as compared to primary stratigraphic trap, okay. So what are the primary stratigraphic trap? Over here I have mentioned, I have listed all of them. Point bar, distributary channel, barrier island bars are barrier bars, okay, self sandstone, submarine fan, delta front sandstone, crevices plate, turbidites, coral reefs, and ramp slopes, okay, whatever, like carbonate reefs, ramp slopes, they are kind of carbonate deposits. And all these I think you must have studied in your sedimentology classes in great detail, but still I would cover a little, just discuss how like they occurs. The first is point bar. Where they occur? They occur along the meandering rivers, something like this. This is a meandering river. This is one of our field, Lakwa and Baral field in Assam, where we have stratigraphic traps. We have drilled several wells in the channel system and we are getting hydrocarbon. So what happens, suppose there is a meandering river, something like this. So if the river is meandering, what happens? The river cuts along this side, it cuts and deposits along this side. Okay, and after certain times what happen, it forms an oxbow lake and river start flowing along this, and we get sand deposits over here, that we call it as point bar deposit, and we have a lot of occurrence of hydrocarbon in such kind of point bar deposits in Lakwa and Bareil fields of ONGC. Okay, and what is distributary channel? You all know, when river is at the confluence along the about to meet the ocean, the gradient of river decreases, and because of the decrease in the gradient, it divides into a number of branches, and when it divides into a number of branches, in between they deposits sand. Okay, and this sand we call it as distributary bar sand. Okay, they can be longitudinal or they can be transtensional, that depends on the, they can be like this or they can be like this. So can anybody tell what are the conditions where you will find longitudinal bar or transverse bar? In general, the longitudinal bar we usually find where the this is fluvial system and this is marine system. In general, we find at those locality where the longitudinal bar where the fluvial system is dominant, such as our Ganges system in Ganga Brahmaputra delta. Okay, and such this kind of system we find where the marine influence or sea water current are very high. Sea water current are very high as compared to fluvial system. For example, on the western coast of India, where we have sea water currents are higher than the fluvial system, current from fluvial system, and we get longitudinal bar where transverse bar, whereas in general in our eastern coast of India we get the longitudinal bars. Okay, barrier island, they are associated with the coastal lands. On the coast we get the deposition of sandbars. Okay, self sandstone as the name indicates, they are usually associated or deposited on the self area. Delta front sandstone as the name indicates, after delta we get the deposition, we have the different part of delta, as you know, delta, pro delta, delta front. Okay, so when we have delta, pro delta and delta front, so when we have the deposition of sandstone in delta front, we call it as delta front sandstone. Crevices splay. What is crevices splay? When there is meandering, and sometimes these levees break out and lead to, during the monsoon season, and lead to deposition of some sediment, and that we call it as crevices splay. Turbidite deposits, you must have studied from you have started study this turbidites in BSc classes also. They are deep water deposits characterized by Bauma sequence and carbonate reef, ramp and slope. They are also a good primary stratigraphic traps. So I will not go in much detail about all these, how they form, but these are the list which we need to understand, and we need to know that they are responsible for the generation for the entrapment of hydrocarbon. Okay, so and this all you have studied in your sedimentary classes in great detail. And next come in further continuation the secondary stratigraphic trap. As I was already discussing that sedimentary stratigraphic traps are associated with unconformity, and this we have already discussed. If we have like impermeous layer after the in the second phase of deposition, then usually we get the accumulation. Apart from this, apart from the unconformity, like a stratigraphic anomaly which is associated with unconformity, we can get accumulation or secondary accumulation by groundwater circulation, by solution, cementation and recrystallization. How does this happen? Like suppose you have a bed dipping something like this. You have a bed dipping something like this, and this is your sandstone. This is your sandstone. Then what happened? Because sandstone, you have sandstone, and suppose this is an exposure, this is surface exposure. So groundwater will percolate. Groundwater will percolate from here, and if groundwater will percolate, and suppose it is a feldspathic sandstone, what will happen? The feldspar will get converted into kaolite because of the weathering, and the extent up to which this water has been percolated, till those places the feldspar, entire feldspar, arcosic sandstone is there, entire feldspar will be converted into kaolinite, and if there is clay minerals, kaolinite over there, it will choke the permeability. Okay, when no permeability is there and water, hydrocarbon and water is migrating from the downside, what will happen? They will start accumulating over here, and that we call it as solution or cementation. Okay, and recrystallization, that is associated with this. Okay, so this is how we can get another way of secondary stratigraphic trap entrapment. Apart from this, sometimes we have combined trap. What are combined trap? Combined trap means when we have both the component, like stratigraphic component, where we have the facies variation laterally. Okay, from one place to another place we have different facies. Okay, and structural trap, that means effect of your fault as well as fold. Those kind of trap we call it as combined trap. Okay, so how the accumulation occur in the combined trap? Over here you can see, this is one of the very good example. Here you can see this is one structure. Okay, but this structure was initially a stratigraphic trap. It would have been like this. There was sand. This is how the deposition would have been taken place. Here it was sandstone or sand, and here it was shale. By later tectonic activity, it is getting folded, and after folding, the charging takes place, and charging is from this side probably or from this side probably. So what is happening? If it would have been like a single facies, then the charging was expected up to here, something like this, the initial figure which we started with. But because it was initially a stratigraphic and later on converted into structural, so what will happen? Wherever in the crustal part we are getting sandstone, we are getting oil accumulation, but wherever we are getting shale is acting as a seal, or it is restricting the migration of hydrocarbon. Okay, so this is how the accumulation is taking place. And when we calculate the reserve, as I have already discussed, for calculation of reserve, what do we do? To calculate volume of hydrocarbon, what we need? area, thickness, porosity, saturation, and formation volume factor, 1 upon formation volume factor. Okay, so for this, what do? We cannot take the entire this thing. This will be the net pay, okay, including the sand. But for here, thickness means the thickness which have the hydrocarbon. We have to eliminate this shale portion. Suppose we have a log, suppose we have drilled a well and we are getting log something like this. This is something like this. Over here, this is GR log, suppose, and here it is 0 to 180 scale. So this will be a sand for this, and this will be a sand, and if we see the bottom one, this will be a sand and this is shale. Okay, this one is shale, this is shaly sand. Okay, this is again shale. So this entire pack will be a gross sand, gross thickness, but when we are going to calculate the reserve, we will take this thickness plus this thickness plus this thickness. Okay, and that we call it as net pay. This is how we calculate the reserve. Okay, net pay means the net of how much thickness is there with the hydrocarbon, and gross means the entire thickness of hydrocarbon column. Okay, and if it is associated with the fault, in case of fault also the similar case applied. Suppose there was a deposition something like this, there is a stratigraphic pinch out, you can see pinch out or wedge out, where this is sand and this is shale, and accumulation is the migration is taking place and accumulation is over here in this part. This part is accumulated with the hydrocarbon. So and if there is a fault, what will happen? This will seep down. Okay, and accumulation again will take place something like this. This is how our combined trap look like, where we have both the component, structural component as well as stratigraphic component. Next come the last one is hydrodynamic trap. Hydrodynamic trap is basically very, like in general it is not very common, and it is a kind of combination of hydrodynamic forces on the structures and stratigraphy. So what happens usually, suppose this is the direction where the hydrocarbon will move, and from this direction water will percolate, the groundwater will percolate and will go down. Okay, so what happens, because of the infiltration of water, the hydrocarbon will not be able to move or migrate upward. So what will it do? If it gets some structure, it will start its accumulation in that particular structure, and that kind of trap we call it as hydrodynamic trap. As the definition says, a downward movement of water prevent the upward migration of oil and gas. Pure hydrodynamic trap is really rare, as I have already discussed, but a number of trap results from combination of hydrodynamic forces and structures or stratigraphy. They are usually associated, but in general this type of trap has been reported from the world, but they are really rare. Okay, sorry. Next, the abundance. We have already discussed in the previous classes that what are the abundance of different type of traps. So we have already discussed that structural trap is around 70% or more than 70%, 75%. So we can see anticlinal traps are 75%, 1% is fault bound trap, salt diaper is 2%, unconformity is 3%, coral reef is 3%, other stratigraphic trap and combination trap combinedly 7% and 9%. Okay, this is how they appears. One more thing, in a structural trap I did not discuss about the salt diaper. What is salt diaper? Usually salt diaper is associated with the Middle East. Here in India we don't get any salt trap associated with salt diaper because we don't have any abundant evaporite deposit in India. So what happened, because suppose there is a deposition something like this, this is shale, sandstone, then suppose evaporite, then again over there sandstone, shale, then this evaporite during deposition, because it is very light and as compared to sand and shale. So what happened during compaction, it formed a bulbous structure within these layers of sandstone, like shale, sandstone, shale. Okay, so when during compaction, this is salt form a bulbous structure within the overlying strata, and when it form a bulb like structure within the strata, it form occluders along this salt. Okay, because salt is impermeable and this is permeable layer. When oil and gas is migrating, it will accumulate along the edges of these structures. Okay, this is how the accumulation of hydrocarbon takes place into salt diapirs. Then the last topic of key element of hydrocarbon, that is generation and migration. Till now, what are the topics we have covered? We have covered the source rock, the first and foremost important component. Then we discussed about reservoir rock, which is responsible for migration of hydrocarbon to the entrapment or trap. Okay, then we discussed about cap rock. There is 3 type of cap rock usually reported: evaporite, shale and carbonates. Okay, then we discussed about traps: structural trap, stratigraphic trap. Structural trap may we have 3 components: fold, fault and salt diaper. In stratigraphic trap, we have primary stratigraphic trap and secondary stratigraphic trap. Primary stratigraphic traps are associated with deposition. Secondary stratigraphic traps are unconformity related or because of the recrystallization, infiltration and cementation. Okay, and after that we are moving on the generation and migration, because we have shale over there we get the generation of hydrocarbon, and we have sandstone where we get the reservoirs. Okay, so how this hydrocarbon moves from the source rock to the reservoir rock is really important to understand, and that comes under migration. Okay, so hydrocarbon, as we have already discussed, hydrocarbon is made up of hydrogen and carbon mainly, and it occurs in gas, liquid and solid, all the forms, and usually formed by transformation of material from either from the marine origin or from the terrestrial origin. And this we have already discussed during the transformation of organic matter to during the transformation of organic matter into hydrocarbon. That is, initially the organic material die and accumulate at a suitable place with provided physico-chemical conditions. What are those physico-chemical conditions? Low kinetic energy, absence of scavengers, rapid burial, all those we have discussed. Then what happens? Biochemical degradation starts. Okay, and biogenic gases in the form of methane are getting eliminated. We discussed about oil window and gas window. Over there initially there was a biogenic gas, after that we get the wet gas zone, फिर oil zone, then dry gas zone. After that this hydrocarbon chain form humine, then after that we get biopolymer, over here it was biopolymer, then we get geopolymer, then we get kerosene and bitumens, and after that the cracking takes place in metagenetic stage. Okay, diagenetic, metagenetic and catagenetic stage. After that we have the metamorphic stage. All those we have discussed in great detail. That means generation part we have already covered. Next come our migration part. The migration means the movement of hydrocarbon from the source to the reservoir, okay, or from the kitchen to the trap. Okay, so this migration has been categorized into 2 parts. One we call it as primary migration, and another we call it as secondary migration. What is primary migration? Primary migration means when the migration takes place from source to carrier bed. From source to carrier bed, it is called we call it as primary migration, and from carrier bed to trap we call it as secondary migration. Okay. Next question come, because what is our source? Our source is shale, and from the start of this lecture I am telling that shale has some porosity, but it is impervious. When shale is impervious, then how this migration takes place? This is really a big question. That's why this primary migration has not well understood till date, but there is several theory and assumptions which have been given by several scientists time to time. Over here we have mentioned three main theories, that the primary migration from the source are in the form of movement of distinct hydrocarbon liquid or gases with or without water. There is one theory which is given by Barker 1980, and there is further another theory that suggests movement in solution with or without water, and the third theory says movement as individual molecule dispersed in water. There is not much difference between as per the assumption of these theories concerned, but still what we say, usually migration takes place together. Okay, usually this is the accepted theory, that usually migration takes place all together, like oil, water and gas, they migrate together, and because of their mobility difference they accumulate at different places at different positions. Okay, so these are some theories which are being proposed for primary migration, but this is the migration theories. Okay, but how this migration takes place if the shale is impervious? Okay, for migration what happens, there is two factors which is involved for primary migration. One is compaction, second is microfracturing. What happens, suppose these are our clay layers and they have the organic material associated with this. Okay, this is clay flakes and this is organic material. So what happens when they come closer, and because of the compaction they come closer because of the compaction, and after compaction, as soon as they are getting converted into hydrocarbon, some small fractures are getting generated in the flakes, lead to removal of liquid material which is generated in between the flakes. Okay, that we call it as microfracturing. And since it is like during diagenesis, okay, during compaction itself, so later on this is getting filled, this is getting further compacted, and we usually don't get much signature of such kind of microfracturing in the thin section which we used to study for the source rock. But in the oil shale where we don't get migration, over there we can get the organic matter which are associated with the flakes. Okay, so these are the two main mechanism which is involved for the primary migration. Okay, and during this primary migration the movement of water takes place in two stages. Okay, so how during initial compaction, this figure demonstrate that during initial compaction at initial phase water escape out. Okay, as usual what happens, suppose we have this is a sedimentary basin, suppose. So this is how the flakes are there and the organic molecule are there. In between what will happen, there will be some water molecule. So during initial compaction maximum water will escape out, but some water, some clay bound water and also some intergranular water will remain along with organic matter, and they escape in the later stage during the hydrocarbon, during petroleum generation, and they escape at the time of escape of hydrocarbon. Okay, and during the course of migration they are separated from the hydrocarbon. That's why these three theories were proposed: movement of distinct hydrocarbon liquid with or without water. Each of these theories says like movement takes place either with water or without water. Okay, so usually this has been accepted that the initial primary migration is along with the water. And if we see the solubility of these hydrocarbons, this is the solubility plot, and if we see the solubility of hydrocarbons, these alcohol and acid are relatively more soluble than that of paraffin hydrocarbons. So they are less soluble, that's why during migration they are easily separated out from the water without much problem. The next come our secondary migration. What is secondary migration? As this picture demonstrates, the movement of hydrocarbon from the source to the carrier bed, we call it as primary migration, and the movement of this hydrocarbon from this carrier bed to the trap, we call it as secondary migration. And what are the factors which are responsible for migration of secondary for the secondary migration? For secondary migration, the main factor which is responsible is buoyancy. Apart from buoyancy, the two more factors are capillary forces and hydrodynamics. Hydrodynamics we have already discussed, and we have so what happens when this hydrocarbon is when this hydrocarbon moves from source rock to the carrier bed? What are the component it has? It has water molecule along with oil and gas. Since water has this oil and gas, they are paraffins, they have very low solubility in the water. So during the course of migration they are separated out because of the during migration itself. So when this carrier the hydrocarbons, soluble or insoluble water in the hydrocarbon migrate with the along the carrier bed, they are separated and segregated as per their density distribution. Okay, and this migration from the source to the reservoir is mainly because of the buoyancy forces. Okay, buoyancy means because of the density differences, they moves upward against the gravity. Okay, and they move upward till the time this because of the buoyancy they move upward till the time they get the pore spaces which are really smaller than the size of the hydrocarbon. After that they continue migration with the capillary forces. So next question come, how where does this hydrodynamics come into play? Hydrodynamic trap we have already discussed. Over there this hydrodynamic trap comes into picture. Okay, when the when the hydrocarbon molecules, this pictorial representation is one of the good representation. Here we can see red is gas and this green bubble is oil, and this blue color is water. This is a standard representation in all the industries. Usually oil is represented by green, gas is represented by red bubble, and water is represented by blue color or blue bubble. Okay, so this is how water oil hydrocarbon is migrating, but because of the water flow over here, they start accumulating at a certain position or at a certain place, because migration infiltration of water resists the further upward migration of hydrocarbon. So for primary migration, what are the factors responsible? For primary migration, the main factors are compaction and microfracturing, whereas for secondary migration, what are the factors mainly responsible? The main responsible factor are buoyancy and capillary forces. Apart from that, you can write hydrodynamics, but hydrodynamics is not doesn't has much role. In some book they write also density differences. Density differences again come in buoyancy, so I have not mentioned that. You can mention that also. So this is all about the migration. We have discussed all these main component, key component of hydrocarbon, starting from the source rock up to migration. The last point, which we call it as timing. Sometimes you will get there in the books, it has been mentioned timing. What is timing? Timing is exactly when your structure is formed before the migration, okay, then you get accumulation, and when the structure is formed after the migration, then you will not get accumulation. That's why the timing is a critical parameter. That means the deformation which is taking place in the area should be before the migration. Only then you can get the accumulation of hydrocarbon in that particular structure which you are dealing with, whether it is a stratigraphic trap or it is a structural trap. With this, I would like to close the chapter of petroleum geology. This is all about the petroleum geology. If any question, you can ring me anytime. With this, I would like to thank you all. Thank you.